Hey everyone, and welcome. Today, we're going to pull back the curtain on something pretty fascinating: how the software we use every single day actually gets built.
I mean, seriously, have you ever really stopped to think about it? How does that app on your phone, the one you can't live without, go from being just a spark of an idea in someone's head to this polished, powerful tool? Well, it's a way more strategic journey than you might think.
And like any big journey, it all starts with a plan, a blueprint, a recipe. But here's the thing, not all plans are created equal. The recipe a team decides to follow can literally make or break the entire project.
So let's start with the fundamentals. What exactly is this plan we're talking about?
Okay, to really get this, we need to separate two key ideas in our minds. First, there's the SDLC, which tells us what we need to do. It's like our list of ingredients. And second, there's the process model, which defines how we're actually going to do it. That's the specific recipe or strategy.
Let's break that down a little more. The Software Development Lifecycle, or SDLC for short, is that basic set of steps. You can think of it as the universal phases that pretty much every project goes through: figuring out what you need, designing it, actually writing the code, testing it to make sure it works, and then getting it out to the world.
So, if the SDLC is the checklist, the process model is the specific game plan your team picks. It's the roadmap that organizes all those tasks. Are you going to do them all in one straight line, or maybe in small, repeating cycles? That choice, right there, is your process model.
All right, let's take a trip back in time. Where did this all start? Well, it started with the original, the OG blueprint for building software, the waterfall model. The waterfall model is exactly what it sounds like. It's a really strict, linear process. Imagine each phase is a bucket of water. You have to fill one bucket up completely before you can let it pour into the next one. And the most important rule, there's absolutely no going back upstream.
The flow here is non-negotiable. You start with requirements, and you cannot move on until they are 100% locked in. Then you design the whole thing, then you build the whole thing, then you test. The biggest risk? You might only find out if you've built the right product at the very, very end of the line.
Now, you might be thinking, wow, that sounds incredibly rigid. And you're right, it is, but it works perfectly for projects where the rules are set in stone and just aren't going to change. A company's internal payroll system is the classic example. The requirements are clear, they're stable, and they're well-defined from the get-go.
But let's be real. The real world is messy. Requirements change, customers get new ideas, so the software industry had to evolve, and that led to a whole new wave of more flexible approaches.
And this evolution happened almost right away. To fix Waterfall's biggest problems, new models started introducing things like feedback loops, ways for users to see early versions, and methods for managing risk from the start instead of at the end.
One of the very first upgrades was simple but kind of brilliant: the iterative waterfall. It keeps that same linear flow, but, and this is a big deal, it allows you to go back a step if you find a problem. It introduced just a little bit of that much-needed flexibility.
To solve that big problem of finding costly errors way too late, the V model showed up. The V stands for verification and validation, and the idea is to pair every single development step with the testing step. This helps you catch issues early, which makes it perfect for safety-critical stuff, like medical devices where you just can't afford a mistake.
But what if you don't even really know what you want to build? That's where the prototyping model is a lifesaver. You build a quick, rough version to get in front of users. They give you feedback, you refine it, and you just keep repeating that loop. It's the perfect solution for that classic "I'll know it when I see it" problem.
Next up is the incremental model, which handles complexity by building and delivering the software in smaller, fully functional pieces. A great way to think about this is the Windows operating system. We didn't get Windows 11 all at once. We got Windows 7, then 8, then 10, with each version adding new features on top of a foundation that already worked.
And for the biggest, most complicated projects, you've got the spiral model. This one is all about managing risk. It combines prototyping with really detailed planning in repeating cycles, or spirals. With each loop, you analyze risks, you build a little more, and you get feedback. It's the go-to for massive projects like defense or aerospace systems where the stakes are just incredibly high.
But all of those were really just evolutions of the same core idea. Then in 2001, something truly different happened. It wasn't just another model, it was the Agile revolution. See, Agile wasn't just a new process, it was a whole new philosophy, and it was summed up in its famous manifesto. This one line is the key: individuals and interactions over processes and tools. Agile decided to put people, collaboration, and flexibility first. In practice, Agile is all about intense teamwork, constant customer feedback, and the ability to change direction quickly. Instead of one huge delivery at the very end, teams deliver working software in these small, rapid cycles called sprints, usually 1 to 4 weeks long, learning and improving with each and every one.
Now, Agile is the philosophy, but teams need a practical way to actually do it. The two most popular frameworks are Scrum and Kanban. Scrum organizes work into those fixed-length sprints, creating a nice, steady rhythm. Kanban, on the other hand, is all about visualizing the work on a board and creating a continuous, smooth flow of tasks.
Okay, we have covered a lot of ground, from the rigid waterfall to the flexible Agile. So, which one is the best? Well, that leads us to the most important part: choosing the right tool for the job. And the answer is, there is no single best model. It all depends on the project. If your requirements are simple and totally fixed, Waterfall is a great choice. If they're completely unclear, you need prototyping. For those huge, risky projects, you'd go with Spiral. And for adapting to constant change, Agile is your answer. Each one is a tool designed for a specific job. So, that brings us to our final thought. Let's make this real for a second. If you were tasked with building the next big social media app, something that needs to evolve with user trends every single day, would you want a fixed, unchangeable blueprint? Or would you prefer a flexible, ongoing conversation? The model you choose really does define your path to success.
You know that feeling when you start a really big project? Maybe it's something exciting, like planning a huge trip or even tackling a major work initiative. There's that initial burst of energy, right? But then sometimes it hits you, okay, where do I actually begin? Or how do I make sure this whole thing doesn't just, fall apart? Well, today we're digging into exactly that, but in the software world. We're doing a deep dive into software development models. These are basically the blueprints, the game plans for how software gets made, everything from your favorite app to, massive systems that run critical infrastructure. We've sifted through the detailed sources you shared, things like technical lectures and guides, to pull out the core ideas. Think of this as your shortcut to understanding the why and how behind building software successfully. And joining me to help make sense of all of this is our expert, who's fantastic at connecting the dots.
It's great to be here. And what's really interesting, I think, is that these models aren't just like dry technical stuff. They're actually different philosophies, different ways of thinking about how to tackle complex problems. By the end of our chat, you won't just know what they are, but hopefully why they matter so much for actually delivering great software that works.
Okay, let's lay the groundwork. Our source materials often distinguish between the software development lifecycle, or SDLC, and these software process models. What's the real difference there? Are they basically the same thing?
That's a really important first step, yeah. So the SDLC, the software development lifecycle, that's the big picture. It's the overall kind of step-by-step process for building any software. Think of the main phases everyone talks about: gathering requirements, doing the design, the actual implementation or coding, testing, deployment, and then ongoing maintenance. It defines what broadly needs to happen.
Yeah.
Right. Now, a software process model, that's different. It's a specific strategy, a structured method that tells you how you're actually going to carry out those SDLC phases. It provides the framework, the roadmap for organizing and managing all the tasks within that life cycle. So SDLC is the general sequence requirements, design, code, test, etc. The model is the specific approach to executing that sequence. Is it step-by-step? Is it iterative? That's the model.
Got it. So maybe like baking a cake. The SDLC is knowing you need ingredients like flour, sugar, eggs, the phases. But the process model is the specific recipe and technique. Are you doing a classic bake one layer at a time? Or maybe something more like iterative cupcakes where you test batches?
Making a perfect analogy, exactly. Waterfall, for instance, is like that classic baking method.
Yeah.
You measure everything precisely, then you mix everything, then you bake, then you frost. Each step is fully done before the next starts.
Right.
It's very sequential. But Agile, well, that's more like your cupcake idea. You make a small batch, maybe get some tasters, that's your user feedback, then you tweak the recipe or decoration for the next small batch, or sprint. Same core phases, but executed very differently.
Okay, that clarifies the fundamental difference. Let's explore some specific models then, starting with the more traditional ones. The waterfall model usually comes up first. What's the essence of that?
Yeah, waterfall is the classic. It's strictly linear and sequential. You have to fully complete and sign off on one phase like requirements before you can even begin the next phase, like design. Then you finish design completely before starting implementation, and so on. It just flows downward step by step like a waterfall, no going back up.
Sounds very structured.
Extremely. Its main advantage, and where it can still be useful, is when the project requirements are incredibly clear, well-documented, and stable right from the very beginning. Think maybe updating a very well-understood system like payroll, where the rules rarely change. It gives you clear milestones for each phase. But the big limitation, the real Achilles heel, is that rigidity.
Right, because requirements do change, don't they, in most real-world projects?
Almost always. And waterfall makes it really difficult and expensive to go back and change something in an earlier phase once you've moved on. If you find a design flaw during testing, well, that's a major problem.
Okay, so that rigidity is a challenge. But the source material mentions an iterative waterfall model. How does that try to address this inflexibility? Does it let you go back up the waterfall?
Sort of, yeah. It's a modification, a more pragmatic take. It still follows the same basic sequential phases, requirements, design, and so on. But it builds in feedback loops between the phases. So if testing reveals issues, you're allowed to revisit the design or even requirements phase to make corrections. It's not quite as strictly linear.
Oh, okay.
It acknowledges that, problems might only surface later.
Yeah.
It makes it a bit more realistic for, say, medium-sized projects where requirements are mostly stable, but you anticipate needing some adjustments based on findings in later stages.
Yeah.
Maybe you can get client feedback after each major phase, for example.
That sounds a bit more practical for many situations. Now, what about the V model? The name itself and the diagrams you see suggest something different. It looks like it really emphasizes testing.
It absolutely does. The V model is essentially a variation of waterfall, but its core focus is integrating testing throughout the entire life cycle, right from the start. Think of the V shape. On the left side, going down, you have the development phases: requirements, high-level design, detailed design, coding. Then on the right side, going up, you have corresponding testing phases directly linked to each development phase. So requirements analysis corresponds to acceptance testing. High-level design corresponds to system testing, detailed design to integration testing, and coding to unit testing.
So testing isn't just an afterthought at the end.
Exactly. That's the key insight. Test planning and test case design happen in parallel with the development phases. As soon as you define requirements, you start thinking about how you'll accept the final system. This helps catch defects much earlier, which is always cheaper and easier. It's really valuable for systems where errors are absolutely critical. Think medical devices, automotive safety systems, avionics, places where failure is not an option and you need rigorous verification and validation.
Okay, so those models, waterfall, iterative waterfall, V model, they all seem to prioritize structure, planning, getting things right up front, very much like traditional engineering.
That's a good way to put it, yeah. Heavy emphasis on upfront definition and control.
But what about projects where you don't know everything up front, where requirements are fuzzy or the market is changing fast or you need to get something out the door quickly? That must require a totally different mindset, right?
Absolutely. And that's where the iterative and adaptive models really come into play. They embrace change and uncertainty rather than trying to eliminate it up front.
Let's talk about the prototyping model. That sounds like it's about building a test version first.
Precisely. With prototyping, the idea is to quickly build a working model. Maybe a rough version, maybe just certain key features of the system. A prototype. You then put this prototype in front of the actual users very early in the process. They play with it, they give you feedback, what they like, what they don't, what's missing.
So you learn by showing, not just by documenting.
Exactly. It's about getting that tangible feedback loop going before you invest heavily in building the final polished product. It's fantastic for clarifying requirements when users aren't quite sure what they want until they see something. Think about designing a new app for, say, a university. Instead of writing a massive spec, you build a few key screens, let students try navigating them, get their reactions, and then refine the design based on real input. Saves a ton of guesswork and potential rework.
That makes a lot of sense, especially for user-facing things. Now, the incremental model. That also sounds like it involves building in pieces. How is it different from prototyping?
It's related in spirit, but the focus is different. The incremental model develops and delivers the final system, but in usable chunks or increments. Each increment delivers a functional piece of the software and typically goes through its own mini SDLC requirements for that increment: design, code, test, deploy. So users get working software progressively, not just a prototype to comment on.
So you could release the core features first, then add more advanced stuff later.
Exactly. Increment 1 might have basic functionality. Increment 2 adds more features. Increment 3 adds even more. Each increment builds on the previous ones and provides real value to the users sooner. This is great for really large systems where trying to build everything at once is just too complex or takes too long, or when you need to get a core product to market quickly and then enhance it. Think about operating systems like Windows. We get new versions 7, 8, 10, 11 each, an increment delivering new features on top of the old.
Okay, I see the pattern here moving away from the big bang delivery towards smaller, iterative steps and feedback. Now, the spiral model. This one sounds complex. It seems to combine iteration with a heavy focus on risk.
You've nailed its key characteristic, risk management. The spiral model is iterative, yes, and it incorporates elements of prototyping, but its defining feature is its explicit, repeated focus on identifying and mitigating risks throughout the project. It visualizes the process as a spiral. Each loop or rotation of the spiral represents a phase, and the project becomes more refined with each loop.
And what happens in each loop?
Typically, each loop involves 4 main activities, or quadrants. First, planning. Defining objectives, alternatives, and constraints for that loop. Second, and this is crucial, risk analysis. Identifying potential risks, technical risks, management risks, budget risks, analyzing them, and figuring out how to reduce them. This might involve building a prototype to test a risky technology, for instance. Third is engineering, actually developing and testing the product for that iteration or loop. And fourth is evaluation, getting customer feedback on what was built, reviewing the results of the loop, and planning the next iteration.
So risk assessment isn't a one-off thing, it's continuous.
Continuous and central. That's the core insight. It's best suited for really large, complex, and inherently high-risk projects where the requirements might be ambiguous or evolve significantly, and where the cost of failure is very high. Think large-scale defense systems, aerospace projects, maybe groundbreaking R&D. I actually worked on a project years ago, a big defense system upgrade, where Spiral was essential. The technology was new. The integration challenges were huge. Security threats were constantly shifting.
Wow.
Yeah. That constant cycle of plan, analyze risk, build a bit, evaluate it allowed us to tackle the riskiest parts first and adapt as we learn more. Without that built-in risk focus, I honestly think the project would have failed or gone wildly over budget. It forces you to confront uncertainty head-on.
That makes sense for those high-stakes situations. Okay, and that brings us finally to Agile. This term is everywhere now. It sounds less like a specific model and more like a whole philosophy.
That's exactly right. Agile isn't one single process model in the same way waterfall or spiral is. It's more of an umbrella term, a philosophy, based on a set of values and principles, famously captured in the Agile Manifesto back in 2001. At its heart, Agile is about embracing change, focusing intensely on customer collaboration and feedback, delivering working software frequently, and empowering self-organizing teams. It values responding to change over following a rigid plan.
So flexibility and collaboration are key.
Absolutely. The core idea is to build software iteratively and incrementally, usually in short cycles called sprints or iterations, typically lasting 1 to 4 weeks. Each sprint aims to produce a potentially shippable piece of working software. It's about continuous delivery, continuous improvement, and being able to adapt quickly as requirements evolve or new information comes to light.
And where does it work best?
It's become dominant in areas where requirements change frequently, market conditions shift rapidly, or close customer collaboration is vital. Think mobile app development, web applications, cloud services environments where speed and adaptability are crucial.
Okay, so Agile is the philosophy, but our source material mentions specific frameworks within Agile, like Scrum and Kanban. How do they fit in?
Right. So Agile provides the values and principles, the why in what. Frameworks like Scrum and Kanban provide the specific practices and structures, the how, to actually implement that philosophy. Scrum is probably the most popular. It's quite structured within its flexibility. It uses those fixed-length sprints we talked about, and it has specific roles. A product owner who represents the customer, a Scrum Master who facilitates the process, and the development team that builds the product. It also has defined meetings or ceremonies like daily stand-ups, sprint planning, reviews, and retrospectives.
Okay, structured but iterative. And Kanban?
Kanban is different. It's less prescriptive about roles and time boxes. Its focus is more on visualizing the workflow, often using a Kanban board with columns like to do, in progress, done, and managing the flow of work through that system. The key principle is limiting work in progress, WIP, to avoid bottlenecks and ensure a smooth, continuous flow. It's very flexible and focuses on optimizing the existing process.
So different ways to achieve that Agile goal of flexibility and fast delivery.
Exactly. Scrum gives you a framework with defined cycles and roles, while Kanban helps you visualize and optimize a continuous flow. Both are powerful ways teams can collaborate effectively, stay adaptable, and deliver value frequently.
Wow. Okay, that's quite a tour from the rigid structure of waterfall all the way to the adaptable flow of Agile and Kanban. It's a lot to take in. So the big question then is, how does someone actually choose? If you're starting a project, how do you pick the right model from this menu of options? It seems crucial.
It is crucial, and there's no single magic answer, unfortunately. It really boils down to analyzing the specific context of your project. You have to weigh several factors.
Like what? What are the key things to consider?
Well, first and foremost, requirements stability. Are your requirements really well understood, documented, and unlikely to change? If yes, maybe, just maybe, waterfall could work. But if requirements are expected to evolve or they're unclear at the start, you absolutely need something more adaptive, agile, spiral, prototyping, incremental.
Okay, requirements volatility. What else?
Project size and complexity. Really large, intricate systems might benefit from the detailed planning and risk management of Spiral, or the rigorous testing integration of the V model. Smaller, less complex projects might be fine with simpler, agile approaches. Then there's risk. How high are the stakes? If you're dealing with safety-critical stuff or major financial risks or unproven technology, a model with explicit risk assessment like Spiral is probably essential.
Makes sense. What about speed?
Huge factor. Time to market. If you need to deliver value quickly and get working features out to users as soon as possible, then Agile, Scrum, or the incremental model are definitely your best bets. They're designed for rapid, iterative delivery.
And the team itself, does that matter?
It does. Team experience and style. Does the team thrive on structure and clear roles? Scrum might be a good fit. Are they more experienced with self-management and prefer visualizing flow? Kanban could be better. Also, how experienced is the team with a particular model? And finally, maybe most importantly for many projects today, how critical is user feedback? If you need continuous input and validation from users throughout the process, Agile methods are built for that. Prototyping too, obviously. Waterfall, not so much.
Okay, that's a great checklist. Let's try applying it. One scenario mentioned in our sources was this. You need to rapidly deploy a nationwide COVID-19 vaccination appointment system while the pandemic is still spreading. Yikes. High pressure.
Yeah, that's a perfect test case. Let's break it down using those factors.
Okay.
First, rapidly deploy. That immediately signals time to market is critical. Speed is essential.
Right. Rules out waterfall straight away, probably.
Absolutely.
Yeah.
Waterfall would be far too slow and rigid. Second, while the pandemic is still spreading, this screams changing requirements. Vaccine availability might change, eligibility rules might change, public health guidance evolves, user needs might shift based on experience. Requirements are definitely not stable.
Very dynamic.
Exactly. High uncertainty, likely high risk associated with system failure or delays. You also need user feedback quickly to improve the appointment process as millions start using it.
So putting all that together, what model jumps out?
It strongly points towards an agile approach, almost certainly using a framework like Scrum or possibly an incremental model.
Why specifically those?
Well, Agile Scrum allows you to deliver functional pieces like basic appointment booking very quickly, within weeks. Sprints. You can get feedback immediately from the first users and adapt to the next sprint. The incremental model also fits because you could release essential booking functionality first, increment 1, then rapidly add features like notifications, reporting, multi-dose tracking, increments 2, 3, etc. You deliver value fast and iterate based on real-world needs in a crisis. Prototyping might be used early on to quickly test interface ideas too. But the core would need that speed and adaptability of agile or incremental.
That makes total sense. You need something that can move as fast as the situation demands. What an exploration this has been. We've gone from those very linear, plan-driven models like waterfall all the way through to these highly adaptive, feedback-driven approaches like Agile. The biggest takeaway for me seems to be that there really is no single best way to build software. It's all about context.
Precisely. The real skill isn't just memorizing the models. It's developing the critical thinking to understand the specific challenges of your project, the requirements, the risks, the team, the need for speed, and then choosing or maybe even blending the approach that best fits that unique situation.
So it's about making smart choices based on the circumstances.
Yeah, applying these frameworks intelligently. That's the key in a world overflowing with information and complexity.
So here's a thought to leave you with. Think beyond just software for a moment. Consider a complex project or goal in your own life. Maybe it's planning a big family reunion, learning a difficult new language, maybe even just finally organizing your garage. Could borrowing some principles from these models help? Like breaking it down into smaller increments, building a quick prototype of your plan, maybe even doing a little risk analysis. What could go wrong with the reunion dinner? Could thinking like a software developer, even just a little, help you tackle those challenges more effectively? Something to ponder. Thank you so much for joining us on this deep dive. We hope it's given you some valuable insights into the fascinating ways things get built in the digital world and maybe even beyond.